For this activity, it says the yellow hexagon will be equal to one whole. And therefore, because we know that it takes two trapezoids to make one whole hexagon, that would make each trapezoid a half, since there's two halves in a whole. And then since there's three rhombi in a whole hexagon, that would make each rhombus a third. And since there's six triangles, that would make each triangle a sixth. So as long as we don't change the fact that the yellow hexagon is equal to a whole, then these values won't change. The red trapezoid equal to a half, blue rhombus is a third, green triangle is a sixth. So we're going to use those values to add some fractions. So let's suppose that we were just given a simple addition, fractions problem. So 1/2 plus 3/6. So the issue with this problem is that they're not the same type of fraction. One of them is halves, specifically 1/2. The other one is sixths, specifically 3/6. So what I would need to do is I would need to make them the same. Now, what we're going to get to and what this is leading to is finding common denominators. So in order to get those fractions to be the same type of fraction, we would change their denomination. We would change their denominator and make the denominator the same. Before we get to that, though, we could actually use pattern blocks, and this would really drive home that point for students of what a common denominator is really doing. So what we could do is, without even knowing the process for finding a common denominator, we can just use the pattern blocks to do this. So if we had the problem 1/2 plus 3/6, we already know that 1/2 is the red trapezoid, so that's one red. And then we know that the green triangles are my sixths, so that means that 3/6 would be three of them. So that's where we're getting this one red plus three green. So we're basically trading our fraction problem for a pattern blocks problem. And now, instead of worrying about how do I do 1/2 plus 3/6, now I'm just worried about how do I do one red plus three green. Now, I still have the same issue with this, that they're not the same, right? This is like adding apples and oranges. Red and green are two different things, so I can't really add them together unless I make them the same. Now, on this one, I think you could probably arrive at the answer without it, but that's just for this problem. And that's just because if you position these just right, so if I take one red and three green, and add those together, but I position them just right, you can see that that takes up the same space as one whole hexagon. So you can see the answer that we'll get here is 1, but that really just works on this problem. So what I would do is I would trade these out. So I would make them the same. So since I'm trying to add one red with three green, I would either make all of them green or make all of them red. And you can see that they've done this for us. So they started with the red. So what they did is they said, well, if I make them all red, then what I can really do here is I can really just replace those three green with one red, right? Because three green is equivalent to one red. So that's what they've done here. And so instead of three green, they've replaced that three green with one red. And of course, we know one red is really equivalent to 1/2. So now this problem, instead of being one red plus three green, has become one red plus one red. Now they're the same, right? So now I could add these together. So one red plus one red would give me two reds. But since we know each red is a half, that's really two halves. So technically we could list that as our answer. However, you could also do this the other way. So instead of changing them to reds, you could change them all to greens. So back when we had one red plus three greens, we could say, well, let's replace that one red and let's just see how many greens it takes to cover it up. In this case, it takes three greens to cover up the red. So really that red is the equivalent of three greens. So that would be if I skipped this step, right? If I start with my original one red plus three green, the one red becomes three greens, right? So this is the same thing here. And so then my problem becomes three greens plus three greens. And again, they're the same thing. Three greens plus three greens is six greens. But in this case, we know greens are a sixth, so 6 greens is really 6 sixths. And so that could also be a correct answer. Of course, we know that if we put those together by using the pattern blocks, we can see that in both cases, whether we put 2 trapezoids together or if we put 6 hexagons, or I'm sorry, 6 triangles together, we get the hexagon, right? So this simplifies to 1 whole or 1 yellow. So let's kind of do the next one then. And they've at least given us some direction on this next one. So if we were starting with this problem, 1/2 plus 1/3, problem is that one is halves and the other is thirds, and those fractions aren't the same. It's like trying to add apples and oranges, right? But if I make them the same, then this would work. So since I don't know yet how to do a common denominator, what I would do is I would use the pattern block. So we know that the red is a half and the blue is a third. So 1/2 plus 1/3 becomes 1 red plus 1 blue. And so then you still have the same issue. They're not the same. This is like trying to add red apples with blueberries, right? They're not the same. So, I can't really add them together, but I could convert them, right? I could say, oh, this many red is equivalent to this many blue, or use something else. In this case, they're suggesting that I use the green, and we know from previously working with pattern blocks that if all else fails, you can break it down into the green, right? So we're starting with 1 red plus 1 blue. So let me get back to my whole here. So 1 red plus 1 blue. They aren't the same, so I can't add them. So what I would do is I would exchange them. I would replace them with greens. So 1 red is actually equivalent to 1, 2, 3 greens. And then 1 blue is equivalent to 1, 2 greens. So this problem really becomes 3 greens plus 2 greens, which of course we know is 5 greens. So that's more simple, right? 3 green apples plus 2 green apples is 5 green apples. In this case, it's green triangles, but same idea. All right, but we know that the green, again, was 1/6. So 3 green is really 3/6. 2 green is really 2/6. So if I add 3/6 and 2/6, I get 5/6. Let's do the last addition and then we'll move on to subtraction. So if we do 1 blue plus 1 green, so let me get back to my start here. So I've got 1 blue plus 1 green. And you might notice right now, depending on how you place those together, that it's actually equivalent to a trapezoid. So hopefully that's what we'll get in the end. But right now, I can't add them together because they're different. Blues and greens are not the same, right? They're not the same size. So I can't add them together. So let's change them out. So greens will always work, right? I know that 1 blue is actually equivalent to 2 green. So we started with 1/3 plus 1/6. A third is a blue and a sixth is a green. And then since I can't add blue and green, I'm replacing the 1 blue for 2 green, which is really the same thing as 2/6. And then this is already green, so I'm just going to leave that alone. 1 green, which is equivalent to 1/6. And 2 plus 1, of course, is 3. So 2 green plus 1 green is 3 green. Or 2/6 plus 1/6 is 3/6. Now we said we hoped that we got a trapezoid here, and they didn't leave a blank for that, although I wish they would have, and I'm going to go ahead and put one there. So now it would just be a matter of simplifying. So just like we would typically not leave our answer as 3/6, we would simplify that down to 1/2. What you can do is you can see, oh, actually those 3 green, they are equivalent to 1 trapezoid or 1 red. And we know from up here that 1 red is equivalent to 1/2. So then let's move on to our subtraction. So let's do 1/2 minus 1/3. So 1/2 we know is represented by a trapezoid. And then I want to subtract from that 1/3, and 1/3 is represented by a rhombus. So what I'm really doing is I'm starting with that trapezoid, and when I subtract, I'm really taking away, right? So I'm subtracting 1/2 minus 1/3, or 1 red minus 1 blue, which really means if I could cover up that blue, I'm looking for what would be left. Again, this one is probably easy enough. You could actually see what's left of the red. If I cover up the part that's blue, all that's left there is a triangle, right? One green triangle is what would be left. But we'll go ahead and do that conversion, right? So since I can't subtract red and blue because they're different shapes and sizes, I would convert them. I would say, well, really, 1 red is equivalent to 3 green. And then 1 blue covers up or is equivalent to 2 of those green. So if I started with 3 green and take away or cover up 2 of those, you can see I'm just left with the 1 green. So if I go back to my worksheet here, I can say, oh, 1 red, that was really 3 green. 1 blue was really 2 green. The greens are sixths, so this was really 3/6 minus 2/6. And of course, 3 minus 2 is 1. So I get 1 green, or 1/6. All right, and then let's do last is 1/2 minus 1/6. This is going to be really similar. So 1/2 is 1 red trapezoid. 1/6 is 1 green triangle. So you can see what we're doing here is we're starting with the red and we're taking away or covering up 1 green off of that red and seeing what's left, right? So we can probably see it here. It's going to fill in, that red spot's going to fill in with a rhombus. But to know this for certain, we would go ahead and exchange it all for green triangles. So we know 1 red is equivalent to 3 green triangles. And then 1 blue, I'm sorry, we're subtracting a green. I need to remember what problem I'm on. We're subtracting 1/6 or 1 green. So then if I take away one of those, right, take away one of those green triangles, I can see I'm left with 2 green triangles, which is equivalent to 1 rhombus. So 1 red was really 3 green, or 3/6. And then I didn't need to change this one because it was already green. 1 green is 1/6. And then 3/6 minus 1/6 would be 2/6. The same way that 3 green minus 1 green would be 2 green. And again, I'm going to go ahead and add an extra blank here. And this is my answer. I just need to simplify it at this point. So this is where I would say, oh, 2 green, that was really the same thing or equivalent to 1 blue. And we know 1 blue from above at the top here, it said 1 blue was equivalent to 1/3. So this would be 1/3.